Okay, we're going to be looking at problem 2.1 on page 26, and this is your first application problem for the application problems in Module 2 assignment. So what we're going to do is you're going to notice that we have 2.1. Now, the problem says to determine graphically the magnitude and direction, but I want you to do it analytically using the sine and the cosine law, just like we've been doing on the last two problems, the sample problems that we did. And we want to find the magnitude and direction of the resultant of the two forces shown. And we are just going to do that. We aren't going to do the parallelogram method or the triangle method just because we're not doing it graphically. We're going to do it analytically or by trig, if you would. Okay. So what we're going to do first is we're going to draw our diagram based on the problem statement. Okay. So again, don't be shy about the size, all right? I encourage you to go bigger than what you think because by the time you add labels and such, it gets super crowded. So this is going to be, I'm going to call it homework problem 2.1, and this is on page 26. Okay, all right. So I am going to make mine horizontal axis, again, as a reference, vertical axis. And this is going to be the center of, I don't know, I think it's called like an eye bolt. All right. And that's going to be the center where those would come together, the application of the forces. So I'm going to start by drawing the 900 Newton force first from horizontal to 30 degrees. And at the tip of my 900 Newton force, I'm then going to draw the 600 Newtons going straight up, just like the first sample problem that we did. Okay. So, and again, I'm just using my straight edge to get decent lines. So this is going to be 900. Okay. And I'm going to I'll call this, I think I'm going to call it A. This is 30 degrees. And A is going to equal 900 Newtons. And then if I draw just a horizontal construction line through here and at like a 45-degree angle, something like this, it looks more like 60, but that's okay. This one is going to be force B, and B is going to be equal to 600 Newtons. All right. And this angle is 45 degrees, about. Okay. So you kind of see, oh, that is not right. That is not right, is it? It's not 45 degrees. Kelly. So from horizontal, it's 30 plus 45. So it's actually 75 degrees. So actually my diagram looks looks closer proportionally. Yeah, make sure, don't glance. Make sure you're going from the reference of 0 degrees. Okay, so that's 75 degrees up. Okay. Now we want to find the resultant of these two forces acting on that eye bolt. So now we're going to start our resultant, the tail at the origin, and its tip is going to go to the tip of the last vector, which was vector B. And this is going to be our resultant. So this looks kind of familiar, doesn't it? Just like that first sample problem that we went through. I just made my I made my arrowhead. I don't know if I like it. I just made my arrowhead kind of extra big there so that you could see it's going up and to the right. Okay. Now I want to find the resultant. Okay. So I need both magnitude and direction. This is a vector. So I need both magnitude and direction of that resultant. Okay. So as I look here, looks very similar to that example. So I'm thinking I should probably be able to use that cosine law. I know two sides, right? I know the magnitude of two sides. Pretty sure I can find this angle theta some way, somehow. Probably just like how I did it last time. And then I can use that cosine law to find the magnitude. So that's going to be my plan. So I'm going to find theta first. Okay. So theta is going to be equal to, so if this is like 0 degrees, it's going to be 180 to this line, right? Minus 75 plus, looks like this is going to be 30 degrees again, right? Okay. So I'm going to have theta is equal to 180 minus 75 plus 30. Okay. So my theta, do you get 135? You guys get that same number? 135. Thank you, Ava. Yes. Yeah. So theta is 135. So now let's use the cosine law to find that resultant. Okay. So I'm just going to cosine law. Okay. Now, whenever we write out and we use an equation like this, we have to write it out in variable form first. Don't put any of the numbers in, just put their variables in first, and then we'll put the numbers. So the side we're going to be solving for is going to be r squared is going to be equal to our side. So it's going to be a squared plus b squared minus 2ab. So we're using the variables we're using the form, the cosine law form, but we're using the variables we have identified here, times the cosine of theta. So when you write this out, I should see an R in your diagram, an A, a B, and a theta, okay? And then now I'm going to put the numbers that I know. So I know that my A is 900 newtons. That's going to be squared. Plus B is 600 newtons. That'll be squared. Minus 2 times 900 newtons times 600 newtons times the cosine of 135 degrees. I snuck it in there. Make sure you add your units of newtons in each one of the areas here, okay? And then I'm going to put R, but then I'm going to take my radical and put it all the way over. See, the whole thing. Okay, so go ahead and calculate your number.
I got a quick question.
Yeah.
Do we have to write that like little second line, or can we just say what R equals if I just punch the whole thing into my calculator?
Oh, you're saying, can you go from here to your final
Yeah,
number? That's
yeah.
totally fine. I'm just
Okay.
doing it for the benefit of, if somebody's kind of along the way and they didn't quite get the right answer, they can kind of see it in stages. Yeah.
All right, got it. Thank you.
You're welcome. Oopsie. Oh, shoots. I don't know if that's the right answer. Is that the right answer? I hope so. I'd have to look back at the answer key, which should
Yeah,
be in there. So this is one of our, that's what you got too? Okay,
yeah. I
perfect.
got it.
Yep.
That's rounded though. Like the exact answer is like point five six
It
six five
is,
four
yes,
eight.
0.566. Yep, 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 yep. But when we're talking about 1,300 newtons, rounding to the nearest pound is pretty reasonable. Okay. So this is our, and I'm just putting this in parentheses, this is our magnitude, okay? So did everybody get the 1391, right? Okay, that's our magnitude of our vector. Remember, to fully define a vector, we need both magnitude and we need the direction. Okay, so last time, if you remember, I'm going to use the same variable. We said that this angle from here to here, we called this angle alpha. Okay, so we want to measure the direction, the angle that that resultant makes to one of our lines on our coordinate system. So either the X or the Y axis. And most of the time it's from the X axis that we want to go to. Okay. So what we're going to have to do is we're going to have to figure out where that is. And last time what we did, and we'll use the same thing, we found what this angle was right there. Okay. Inside of our triangle. Okay. And we're going to call that angle beta. Okay. Just like we did last time. And then we'll add 30 to get alpha. Okay, so we kind of do this in two stages. All right. So to get beta, we know the length of all of our sides now. So we can use the sine law, right? To get beta. So go ahead and use that sine law. Okay. And we want to find beta. So we're going to use sine beta over the length of B, which is 600 newtons. Okay. So sine of beta over 600 newtons is going to be equal to, and we really have a choice. I mean, we could figure out this angle, but we already know the 135, right? And that's opposite the resultant that we just calculated. So we're going to say the sine of 135 divided by 1391 newtons. Okay, so our only unknown here is beta. All right, so I am going to take my 600 newtons. I'm going to multiply it up on top here. So sine beta, I'll get that number first. You don't have to write out this separate line, but just in case you don't get the same number I do, you can kind of compare as we go along. Oh, that's really not a final answer. So I don't want to put a box around this one. This is not a final answer. So for beta, did you get 17.8? Yeah, I got one, yep. Give me a chance to get that one. Now that's not a final answer, so don't put a box or a circle around that one. We only want boxes and circles around final answers, okay? There's intermittent answers, okay? So beta, we know is 17.8 degrees. So now we want alpha from 0. So alpha is going to be equal to beta, C plus 30 degrees, right? Because we want to go all the way from here. This is 30 plus beta. So that's going to equal 17.8 degrees plus 30 degrees. So our alpha should be 47.8 degrees. You guys get that same number? Yeah, thank you, Jaden. And if we look back, my hope is that these both match. And I think somebody did confirm that for us already. So if I go back to our application problems in module 2, oh, look at that. 1390. The book, I use the answers from the book. They always round to 3 significant digits. So they actually went to 1390. Our answer came out to 1391.5 or 1390.56, whatever it was. So they rounded to 1390 just because it's 3 significant digits. And then 47.8 was exactly what I got to. Okay. As long as your numbers are within a reasonable value, thinking about they're going to round to 3 significant digits. I always tell students when you are inside the problem here, okay, hold a couple decimal places and then round your final answer. You will always be closer, in the end. Don't round inside of, if you would, the problem. Okay. All right. So for this one, make sure that you have a diagram with your, your labels. Then if you're calculating a resultant, capital R, if you're calling it resultant, I should see an R is equal to. Make sure the newtons are in here. Make sure the newtons are in all the phases of the problem. And then I should see an R up here so I know exactly where it's at. You have it represented. Okay. Then down here, beta and alpha, I need to see where those are as well so that, if you're calculating values, they should be up in your diagram somewhere. Think about too, not only for my sake, when we have our midterm and our final exams, you get to use your homework problems. And if they're nice and easy to read, easy to follow, then it's going to be easier to do the exam. Okay?
I have a quick question.
Yeah.
So for the cosine part, like I understand, or not cosine part, sorry, the sine part, how are you
Mhm.
where you like what information makes you want to put the 600 newtons on the bottom and then
Mhm.
because I keep thinking like SOHCAHTOA, but I don't know if I'm not like
Oh yeah, no,
looking it up.
no. You know what? You could put the 600 on top. It's just that when you set up your equal sign here,
Uh-huh.
however you set it up here, you have to set it up the same format on this side. So if you put
Uh-huh.
your angle on top and your length on the bottom, it has to be that same way on both sides. The only reason I picked to put the sign on the top here was because this was my only unknown value. And I
Okay.
like having that in the top, if you would. It's just
Mhm.
less rearranging I have to do.
Okay. And then why is the 600 why I'm more of asking why are they why is that 600 there? Why is it when
Mhm.
how can I put
Mhm.
together that
Yeah.
equation looking
Yeah.
at the
Yeah.
diagram? So,
So whenever you use your ratios for the sine law, the angle theta is going to be over the side, the length of the side opposite, which is B here.
okay, that's opposite. Okay,
And
got
that's
it.
600. Yeah.
600. Okay.
And then the theta is opposite the resultant. And then if we would
Okay.
have an angle here, this would be opposite the A.
Okay, got it.
Yeah, yeah, yeah. I know it's kind of a flat triangle, so it doesn't feel as opposing, but
Hmm.
yeah, it's the angle opposite the side. That's what the sine law is. Yeah.
Got it. Thank you.
You're welcome. You're welcome. Any other questions? And don't feel bad if that's a little bit rusty. I'm glad you asked that question because you might not be the only other person that's been like, "Oh, it's a little while since I had that." So I'm glad you asked that. Thank you. And the cosine law familiar to everybody? Feel comfortable with that? Okay. If not, let me know, and I'm happy to go over it as well. All right. So what I'm going to do is I'm going to stop our recording here.